All right, let's talk about first taking, so if I was looking at y'all's packet, and I'm looking at number, look at number 12. We're multiplying fractions, aren't we? Aren't we? Yeah, so let me show you how to do that. This is 4. Dot numbers and fractions. We are talking about using decomposition to add and subtract. Okay, so put a star by number 12 and remind me to go over there. Okay. If I give you something like this, if I give you 1/2 minus 1/4, would you know what to do? Now let me write this a different way. You write it like this. You know Mr. Gray likes to write his half. Do I like to write them side by side or do I like to stack them?
Stack them.
I like to stack mine. Okay. I know it's easier if I stack them. It's easier to draw those pictures. Every fraction starts out as a what?
Whole.
Whole. Put a whole bar. I'm going to put a whole bar down here. Notice they have to be the same size. How many slices will this 1/2 be broken into?
2.
2. Each side equals 1/2. How many will I break them down into down here?
4.
4. Each side equals what?
1.
I want to look at what I have to see. What can I rewrite so they have the same denominators? I want them to have the same denominators, okay? How many of these 4ths does it take to make 1/2? Well, I first need to figure out, what does 1/2 look like? Well, 1/2 is one whole block shape. Okay. So how many of these little blocks does it take to make? Huh?
2.
Who couldn't see that? If I look at where this block meets these, how many blocks are covered? 2. 1/4 plus 1/4 equals
2.
So this 1/4, excuse me, I didn't mean to do that. The 1/4 isn't going to change. I need to change this. This 1/2 equals what? What you just said. No, 1/4 plus
2 4.
1/4 plus 1/4. Okay, that's what that turned into. This can stay what? 1/4. Because I needed to have a denominator of what? 4. What's 1/4 plus 1/4?
2 4.
Subtract. Can I subtract 1/4 from 2 4?
Yes.
And I get 1/4. Okay? Now, some of you would have done this. You know, what's the relationship from 2 to 4?
2 4.
Times 2, right? So multiply this times 2, and that's times 2. You change the small one.
That's what I
Change
did.
the small one.
At Velcro.
This one won't change. This one turns into 2/4. Now I can do 2 minus 1/4. Get the same thing.
I did on this one.
Same thing. How many done that? Let's do another. And again, this is being recorded. Okay. So if you can either draw the pictures or use common factors. But you always change the one that has the bigger denominator or the smaller one. The smaller one. Okay.
Oh my God, my eyes bugging.
Give me see what that. I'm gonna do number 3. One like number 3. Let's do 8/10 minus 2/5. Okay? First, I'm going to draw my pictures. Let me do it that way first. All right, I'm going to draw. Always start out with what?
A hole.
Hole bar. Okay. A hole here. A hole down here. What am I breaking this top one into?
Tens.
Why?
Because that's the denominator.
Bingo. Five, 6, 7, 8, 9, 10. Each piece is worth how much?
8 wins. Sorry,
What? 1/10. Remember? What's that magic word that we learned?
Unit fractions.
Unit fractions. What's a unit fraction?
Any
Any fraction that has 1 in the numerator. These are tenths, or 1/10 a piece. I break these into fifths. Each is worth what?
5. I mean, 1 fifth.
Thank you guys. Think before you speak. Okay. Which one am I changing?
The 2 fifths.
The 2/5, the small one. Okay. I need to color in 2. Because that's all I'm recognizing. How many of these tenths equal 2/5?
4. 2? What? The
4. 4. Okay. It looks like 5, but that's because Mr. Gray's boxes are what?
Small.
They're not equal. So now I might need to redraw my boxes. Each box should be the same size. Watch. What about this? 1, 2, 3, 4. Are they equal now?
Mm-hmm.
Yeah. So how many tenths
4.
does 2/5 equal? 4. So 1/10 plus 1/10 plus 1/10 plus 1/10 gives me what?
14.
Yeah. Oh, it goes down here. I'm sorry. And then up here I can keep what?
8
8/10. Because I'm only changing the small one. And I get what? What's my answer? 4/10. 8 minus 4 is 4/10. What if I hate that way? I don't like that way. Mr. Gray, I can't draw, so my pictures don't line up nice and pretty like yours. What's another way I can do it? I can do 8/10 minus 2/5. Which one won't change? 8/10. Which one will change?
2/5.
What, the 2/5. 2/5. What do I multiply both the top and the bottom by to get to 10?
8.
From 5 to 10, what do I multiply? So multiply the top by 2. 2 times 2
4.
over 5 times 2. 10. Do they have the same denominator? Yes. Now I can subtract them. 8 minus 4. 4. Same way.
So, Mr. Gray, the bigger number on this one stays the same?
Always. Always. Not bigger number, bigger denominator. The one that has the bigger denominator won't change, just bring it over.
And then
We look at the one with the smaller denominator to see how many unit fractions of the bigger denominator do we need to replace it with. You see what I'm saying? And it's the same way. How did I get from 5 to 10? Times 2. How did I get from 2 to 4? Times 2. Just 2 different ways to do the same problem. Okay. Is it making sense?
Mm-hmm.
Okay, you want to do one more?
Yeah.
Let's do one more. Sure.
Hey, Mr. Gray?
Yes.
Well, I'm not going to say it right now. This is about math.
Let me give you one more. Okay. One more. 6/12. over 12 minus 2/3.
Three spaces.